recommended distance between underground electrical service from a house to a shed varies depending on local codes and regulations. However, the National Electrical Code recommends a minimum separation of 18 inches, which is 457 millimeters, from the edge of the trench to any gas line. The recommended distance between an underground natural gas line and any other structure, including a house or shed, is also regulated by local codes and regulations. However, the American Petroleum Institute recommends a minimum separation of 10 feet, which is 3 meters, from the edge of the gas line to the nearest building. In general, the following guidelines should be followed when installing underground utilities. Firstly, maintain a safe distance between utilities and other structures. Secondly, avoid crossing utilities perpendicularly. Thirdly, if utilities must cross, use a 90-degree angle and install a marker tape or other indication of the crossing point. Fourthly, call before you dig to locate existing utilities. It is important to consult with local authorities and utility providers to determine the specific requirements in your area. These guidelines are general recommendations and may not be applicable in all circumstances. When dealing with electrical installations, safety is paramount, and adhering to established codes and standards is not just a good practice, but a legal requirement in many jurisdictions. The National Electrical Code, or NEC, serves as a comprehensive guide for electrical installations in the United States. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Regarding underground electrical services, the NEC provides specific guidelines to ensure the safety of both people and property. One crucial aspect is the burial depth of underground cables and conductors. The NEC specifies minimum burial depths based on voltage levels and installation locations. For example, direct burial cables operating at 600 volts or less typically require a minimum burial depth of 24 inches in residential areas. However, this depth may vary depending on the specific installation and local requirements. It's essential to consult the NEC and local codes to determine the appropriate burial depth for your specific situation. Another important consideration is the type of cable or conductor used for underground installations. The NEC specifies approved cable types for direct burial applications, such as underground feeder, or off cable and direct burial, or DB cable. These cables are designed to withstand the harsh conditions of underground environments, including moisture, temperature variations, and physical stress. When installing underground electrical services near other underground utilities, such as natural gas lines, maintaining a safe separation distance is critical. The NEC recommends a minimum separation of 12 inches between electrical cables and gas lines. This separation helps prevent accidental contact between the two utilities, which could result in a dangerous situation. In addition to separation distances, the NEC also addresses the issue of grounding and bonding for underground electrical systems. Grounding and bonding are essential for providing a safe path for fault currents, which can help prevent electrical shock and fire hazards. The NEC specifies grounding and bonding requirements for various types of underground electrical systems, including service entrances, equipment grounding conductors, and ground rods. When working with underground electrical services, it's important to follow safe work practices to minimize the risk of electrical shock or other injuries. Always de-energize electrical circuits before working on them, and use appropriate personal protective equipment, such as rubber gloves and safety glasses. In addition, be aware of the location of other underground utilities, such as gas lines, water lines, and communication cables. Call before you dig to have these utilities marked before you begin any excavation work. Now let's delve deeper into the American Petroleum Institute, or API, recommendations for natural gas line installations and their proximity to other structures. The API sets standards for the petroleum and natural gas industries, covering a wide range of operations from drilling and production to transportation and distribution. When it comes to underground natural gas lines, the API focuses on ensuring the safe and reliable delivery of natural gas while minimizing the risk of leaks or explosions. One of the key considerations is the material used for the gas pipeline. The API recommends using high-strength steel pipes that are specifically designed for natural gas transmission. These pipes are coated with protective materials to prevent corrosion and ensure long-term durability. The depth at which a natural gas line is buried is also crucial for safety. The API typically recommends a minimum burial depth of 30 inches to protect the pipeline from physical damage and temperature fluctuations. This depth may vary depending on local regulations and soil conditions. Proximity of natural gas lines to buildings is another important aspect covered by API guidelines. The API recommends maintaining a minimum distance of 10 feet between the gas line and any building foundation. This separation is intended to reduce the risk of damage to the building in case of a gas leak or explosion. In addition to separation distances, the API also emphasizes the importance of regular inspections and maintenance of natural gas pipelines. These inspections are conducted to detect any signs of corrosion, leaks, or other potential problems. If any issues are found, they are promptly addressed to prevent further damage or safety hazards. The API also provides guidance on how to handle emergencies involving natural gas leaks. It recommends that anyone who suspects a gas leak should immediately evacuate the area and call the local gas company or emergency services. It's crucial to avoid any actions that could ignite the gas, such as using electrical switches or open flames. In situations where underground utilities must cross each other, it is essential to follow specific procedures to minimize the risk of damage. The NEC and API recommend that utilities cross at a 90-degree angle whenever possible. This minimizes the area of potential contact and reduces the likelihood of damage. When utilities cross, it's also important to install a marker tape or other indication of the crossing point. This helps prevent accidental damage during future excavation work. The marker tape should be buried a few inches above the utility line and should be easily visible to anyone digging in the area. In addition to physical separation and marking, coordination between utility companies is crucial when installing or maintaining underground utilities. Utility companies should communicate with each other to share information about the location of their facilities and to coordinate their work activities. This helps prevent conflicts and ensures the safety of workers and the public. When planning an underground utility installation, it's also important to consider the environmental impact. Excavation work can disturb soil and vegetation, and it can also release pollutants into the air and water. To minimize these impacts, it's important to use best management practices, such as erosion control measures, dust suppression techniques, and proper disposal of waste materials. Another consideration is the potential for damage to underground utilities from tree roots. Tree roots can grow into underground utility lines, causing damage and disruptions. To prevent this, it's important to select tree species that are less likely to invade underground utilities. It's also important to maintain a buffer zone between trees and underground utilities to minimize the risk of root damage. Before starting any excavation work, it's essential to call your local one-call center to have underground utilities marked. This service is free and it can prevent serious injuries and property damage. When you call, you'll be asked to provide information about the location and scope of your excavation work. The one-call center will then notify the utility companies in your area, who will send representatives to mark the location of their underground facilities. It's important to wait until all utilities have been marked before you begin digging. The utility markings are usually color-coded, with each color representing a different type of utility. For example, red typically indicates electric lines, yellow indicates gas lines, and blue indicates water lines. It's important to respect these markings and to avoid digging within the tolerance zone, which is typically 18 inches on either side of the marked utility. If you must dig within the tolerance zone, it's important to use hand digging techniques to avoid damaging the underground utility. Hand digging is slower and more labor intensive than using power equipment, but it's much safer. When hand digging, use a shovel or trowel to carefully remove soil around the underground utility. Be careful not to damage the utility line. If you do damage an underground utility, it's important to report it immediately to the utility company. Even a small nick or scratch can weaken the utility line and cause it to fail in the future. When backfilling an excavation, it's important to use the proper materials and techniques. The backfill material should be free of rocks and debris that could damage the underground utility. It's also important to compact the backfill material to prevent settling, which can damage the utility line. In addition to the NEC and API, there are other standards and guidelines that may apply to underground utility installations. These include the National Electrical Safety Code, or NEC, which provides guidance on the safe installation and maintenance of electric power and communication lines, and the Pipeline and Hazardous Materials Safety Administration, or PHMSA, which regulates the transportation of hazardous materials by pipeline. It's important to be familiar with all applicable standards and guidelines before undertaking any underground utility installation. When dealing with electrical systems, it is important to understand the basic principles of electricity, such as voltage, current, and resistance. Voltage is the electrical potential difference between 2 points in a circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of current in a circuit. It is measured in ohms. Ohm's law states that the voltage across a conductor is proportional to the current flowing through it and the resistance of the conductor. This relationship can be expressed as volts equals amps times ohms. The power consumed by an electrical circuit is equal to the voltage times the current. Power is measured in watts. Electrical circuits can be either series or parallel. In a series circuit, the components are connected end to end so that the current flows through each component in turn. In a parallel circuit, the components are connected side by side so that the current has multiple paths to flow through. The total resistance of a series circuit is equal to the sum of the individual resistances. The total resistance of a parallel circuit is less than the smallest individual resistance. Electrical safety is of utmost importance when working with electrical systems. Always de-energize electrical circuits before working on them and use appropriate personal protective equipment such as rubber gloves and safety glasses. Be aware of the location of other underground utilities such as gas lines, water lines, and communication cables. Call before you dig to have these utilities marked before you begin any excavation work. When working with natural gas systems, it's important to understand the properties of natural gas. Natural gas is a colorless, odorless, and flammable gas that is composed primarily of methane. Natural gas is lighter than air, so it tends to rise and dissipate quickly. However, if natural gas accumulates in a confined space, it can create an explosive atmosphere. Natural gas is transported through pipelines at high pressure. The pressure in a natural gas pipeline can range from a few £100 per square inch to several £1,000 per square inch. Natural gas is regulated by the Pipeline and Hazardous Materials Safety Administration, or PHMSA. PHMSA sets standards for the design, construction, operation, and maintenance of natural gas pipelines. Natural gas leaks can be dangerous, so it's important to know how to detect and respond to them. The most common sign of a natural gas leak is a distinctive rotten egg smell. Natural gas is naturally odorless, but gas companies add a chemical called mercaptan to give it a distinctive smell so that leaks can be easily detected. If you suspect a natural gas leak, evacuate the area immediately and call the gas company or emergency services. Do not use any electrical devices or open flames, as these could ignite the gas. Natural gas is a valuable energy source, but it's important to handle it safely. By following the guidelines and recommendations outlined in this discussion, you can help ensure the safe and reliable operation of underground electrical and natural gas systems. It is crucial to contact your local utilities and local governing authorities to be compliant with all applicable rules, regulations, and codes. The information provided here is for informational purposes only and does not constitute professional engineering advice. Consult with a qualified professional for specific applications.